For this worksheet, we need to look at the sample problems that we were given on this side and write down how the big O notation works with all of these. If we look at number 1, we see that we have a statement here that gets executed once, a statement here that gets executed once, and a statement in here that gets executed n many times. We also have these statements that are going to get executed. They contribute with this right here. So whenever it gets executed, this is going to get executed as well, and so is this. So all of this in here is going to be executed n many times, which means our answer is going to be O n. For number 2, we can look at the statements first that are going to be executed once. We have this one right here, which is going to be executed once, and this one down here, which is going to be executed once. Inside of our in case for loop, this one, we are going to have a statement right here, and right here that gets executed n many times. And this outer for loop is also going to get executed n many times. So this means that our answer is going to be big O n squared. For number 3, we're going to mark our statements that get executed once. Inside of our middle for loop is where we're going to look next, and we see that this gets executed for as long as j is less than 10. So this is going to get executed 9 times, but we also have this statement in here and this statement right here. So it's going to get executed 11 times. Outside in here, the outer for loop, we're going to have this be executed n many times. From here, we can rewrite this as 11n. Since our 11 is constant, it gets absorbed into the n, and we're just left with big O n as our answer. For number 4, we are going to look at the statements that get executed once and mark them. Now we look at our for loops. We have our inner for loop that we need to look at. This gets executed n many times because it is a statement right here, and in here, and in here, and they get executed for as long as our array length is. And then same thing on the outside. So this is just going to be big O n with a squared. For number 5, we have a pre-statement that we need to look at, that AR length is a power of 2. That means this could possibly be 2 to the 5th, like this. We can look inside of our code. You see that this gets executed once, and so does this. So we're not really going to look at them. We're going to look inside of our for statement. We have a statement in here, here, and here that's going to execute. If our array is 2 to the 5th, that means it's equal to 32. We can write this code out, and we can say that if we go into our for loop for the first time, the sum is going to be a number, and our index for this is just going to be 1. Now doing this again, we're going to have 2 index 2, and then some value 2 that's going to be associated with 2, and then we can just write out that these are just going to be some values. We don't really care about them, but we care about the indexes that's going to be incrementing. So we're going to have 2, and then 2 times 2 is 4. On the next loop, it's going to be 4 times 2, which is 8, and 8 times 2, which is 16, and 32, and so on and so forth. Since it's increasing every single time like this, and it's going like this, we say that it is a big O, and then inside we have a log n, and that is our answer.